Welcome back to our Certified Entry-Level Python Programmer course. In this video, we're going to discuss recursion. This is when a function calls itself. That's right, the function literally calls itself and recurses. Now, before we get into this, let's answer a question that you may have had, and that is, can we pass something like a list into our function? And the answer is, yeah, we could pass a list into the function, and we're going to want to iterate through that list most likely in our function. And so look at this. We define an iterative sum function here that's going to take some numbers, and it's going to start with a total of 0. And then for every one of those numbers, it's going to add that number to a running total and then return that total. So you can see in this example how, yes, a function could take a list, and then you're seeing how we could actually iterate through this list and return some kind of a value. Let's just play with this, make sure it works. So we'll go over here to our idle shell and we'll paste in this function definition, and then we'll call it. So iterative underscore sum, and then we are going to provide it a list, 10, 20, 30, for example. And what we would want to do is print this result, obviously, or we're not going to be very happy with running this function call. Alrighty, there we go. And look at that. It just does its job just like we want it to. Sure, just iterate through this list of numbers that we have provided. And in this case, we're going to add them up. Okay, well, as you might guess, this example can be done with recursion. And if we introduce recursion into this equation, it's going to be a lot fewer lines of code. Yeah, it's a simpler way to do it. So let's check it out. Let's have the function call itself. I've got another example here for us, and it uses recursive function logic. Check this out. Here's our recursive sum of our numbers. And notice I say if not nums, then return 0. So we have a little built-in logic against there being absolutely nothing provided as far as numbers go. But then we're going to return the numbers added up. Yeah, notice we're using the first number, and then we're adding it to the next number, and we're doing the whole next number thing by calling the very function in the function. So we're calling the function in the function we're defining. Woo! This is getting real matrix and bizarre, isn't it, right? No, not matrix, Inception, right? A dream within a dream. Yay to all you Christopher Nolan fans out there. All right. So, and by the way, I should make clear that I'm a Christopher Nolan fan myself for most of his films. All right, so anyways, imagine this. We can call the function within the function. Yeah. And if I wasn't worried about the kind of error check there on what happens if there is, no value inside of our list, then this is all done with one line of code inside of the definition. So let's go ahead and just make sure this works. As you might guess, it's going to work just great. And then I want to conclude here, making sure you understand a caveat about these two approaches that we've looked at. So I'm going to print the recursive sum, and I will go ahead and provide a list just like before of 10, 20, 30. And we need to get all of our parentheses in place there. And you can see it does just what the previous code did. And by the way, the previous code, the iterative way we did it, if I provided nothing to this, an empty string, it would have returned the total is 0, just like this returns the total is 0. In fact, let's check that out real quick. Let me, man, oh man, I could never get the command shortcut right. I apologize for all of you that have seen that a bazillion times in all of these episodes. Anyways, what are we going to do here? We're going to give it an empty list, and sure enough, it returns 0, just like our non-recursive, our iterative sum would have done. So, what's the deal? Why wouldn't we always just use a recursion like this? It works so easily and beautifully to get the job done. Well, one caveat I want to tell you about using recursion is because what's going on here is there's actually another list being created. This is creating a slice, isn't it? And adding it. So it's not like this is the most efficient thing for Python to be doing. There are limits to how deep the recursion can go and stuff like that. So just suffice it to say that there are limits on recursion in Python. So for massive lists, for instance, we might be feeding the application. Iteration is the way to go. But you can use recursion and enjoy it, especially if you have a super short list like we do. Yeah, so if the list is super short, the recursive approach is not going to cause a problem at all for Python. All right, those get into more advanced topics. As you might guess, the main thing I wanted you to take out of this video, two main things, was that, yeah, we can feed things like lists into our functions. And when it comes to stepping through those lists, we have two approaches. We can iterate or we can use recursion. Thanks so much for watching.